how to factor. Be like Schultz. What? Can you teach me how to factor? You know why? Because all the students after. And hey, all I need is a real good quadratic.
Oh, hey, hi, how y'all doing? I guess it's that time. Teach me how to factor. Let's do this. Teach me how to factor. Teach me how to factor. Yeah, you know you want to know how. Hey, we're going to talk about it today. Teach me how to factor. As a reminder, factoring a quadratic is the process of manipulating a quadratic from standard form to change it into intercept form. This allows us to see our roots, also known as the zeros, solutions, x-intercepts, quickly and easily. So let's do this. We've been working on this all week. We learned the process. And the process was, hey, let's start off with a quadratic and let's answer a few questions. Let's start with one here. Let's say I have x squared minus 3x minus 10. Let's just say I have that one. And that thing could be set equal to the 0, which is what we want it to be equal to. Or it could be set equal to y, or it could be set equal to f of x. Don't forget that. We haven't really spent much time on that, but that could be the case too. But regardless, we want to factor it. We always ask the first question, is there a GCF? Well, I also told you if there's no leading coefficient, there's not going to be a GCF. So let's move on to question 2. Is there a leading coefficient? No, in this case, there is not. So that's when we worked to this side of our process. So splitting signs, x in each. Then we look at our signs. This sign tells us whether it's going to be the same or opposite. If it's a plus sign, they would be the same. If it's a minus sign, they'd be opposite. This is minus, so we would have a plus and a minus. Then we list the factors of the constant. So 1 times 10 is 10. 2 times 5 is 10. Which of those sets of factors comes together with opposite signs to get me a 3? 2 and 5. And the larger number gets the sign from the middle, so 5 goes with a negative and 2. So our solutions are negative 2 and a positive 5. Cool. That's what we've been working on. We've been dealing with all these ones that had no leading coefficient. Well, today it's time to learn the box method. The box method. So now we're going to have a leading coefficient and we're going to learn the box method. So let's start with a couple here and let me teach you the box method. Let me take a quick time out here, and I'll be right back. All right, sorry about that. Let's get going here. So we're going to keep the same process. When I say the same process, you still got to ask yourself, is there a GCF? Is there a number or letter that goes into all 3 terms of the quadratic? In this case, this first one there is no. Then is there a leading coefficient? And my answer is yes. So the first thing I say is box method. And you may be saying, hey, coach, what's the box method? So I say, hey, we're going to draw a box. Okay. And we're going to put window panes in that box. Then we're going to take this first term and we're going to put it in the upper left-hand corner. Okay. So 3p squared. And then we're going to take our last term. We're going to put it in the lower left box. Excuse me, the lower right box. So negative 5. Then, once we have those 2 numbers in, we're going to take those numbers and multiply. 3 times a negative 5 is a negative 15. You remember how we listed all the factors of the constant? We're going to list all the factors of this number that we just multiplied together. So, I've got 1 and 15, 3 and 5, and that's it, right? Which of those come together with opposite signs? How do I know it's opposite signs? Because there's that negative. With opposite signs, to get me a negative 2. The larger number gets a sign from the middle, so that 5 has to be negative. Why? Because that 2 is negative right there. So the larger number gets assigned to the middle. So I'm going to put that -5 and the 3 in the other two boxes, and I'm going to add the variable with both of those. That's important. Okay? And it doesn't matter which one you put in which box. I could flip-flop those. It's not going to make a difference. Okay? That is filling our box for the box method. Then the last thing we're going to do is we're going to look for a GCF or a common factor between these two. Okay, well, 3 and 5, there's nothing, so I can just pull out a P. How about here? Well, again, I can only pull out a 1. How about going up and down? Well, I can pull out a 3 and a P. And then again, going up and down, I can pull out a 5. Now, notice that this negative sign is right here. Since that's negative, this thing on the outside is going to be negative. And that is the factored form of my equation. So I have 3p minus 5 times p plus 1. Why is it a plus 1? Because that was a positive 1. Now, how would I check myself to make sure that I did that correctly? Well, I could FOIL it back out to make sure that it worked. Let's try that just for fun. 3p times p is 3p squared plus 3p minus 5p minus 5. Combine my like terms there in the middle. 3p squared minus 2p minus 5. And that's what I had to start with. That is the box method. What? Nah, come on now. It wasn't that bad. Let's try it again. Okay. Number 2. Is there a GCF? Is there a greatest common factor? Let me go back to red. Is there a greatest common factor between 2, 3, and 9? No. Okay. Is there a leading coefficient? Yes. So I'm going to use the box method. First, in the upper left, 2n squared. Last, in the bottom right, multiply those numbers. 2 times a -9 is a -18. And list all the factors of -18. 1 and 18, 2 and 9, 3 and 6. And that's it, right? Which of those come together to get me a 3? 3 and 6. The larger number gets assigned from the middle. So I'm going to get a positive 6n and a negative 3n. How do I know one's positive, one's negative? Well, because that sign right there tells me that they're opposite. Okay? All right. Now, I got to factor out. I'm going to find my greatest common factor here. Well, I can pull out a 2 and an n. How about here? Well, since this is negative, whatever I pull out is going to be negative. Now I can pull out a 3. How about up and down? Well, 2 and 3, nothing, but I can pull out an n. How about these two? I can pull out a 3. So my solution is 2n minus 3 times n plus 3. And that's the factored form of that quadratic. And that is the box method. I hope that you're enjoying this. Let's try another one. Let's go on to number 3. Start with asking yourself, is there a GCF? No. Is there a leading coefficient? Yes. So we're going to go to the box method. What goes in this box here? Yep, the first term, 3n squared. What goes in this box? Yes, the constant. Then I take those two numbers and multiply them together. 3 times 4 is 12. What are all the factors of 12? 1 and 12, 2 and 6, 3 and 4. Which of those come together with the same signs? How do I know the same signs? There's the same signs, and they're both negative. So same signs to get me an 8, 2 and 6. And they both got to be negative. So I have a negative 6n and a negative 2n. Again, it doesn't matter which one you put where, whatever floats your boat. And then it's not going to make a difference in your answer. It's just going to put them in different locations. I'll show you that later when I'm there. Okay, so now I find out what is my greatest common factor here. 3n. What is my greatest common factor here? Negative 2. How do I know it's negative? Because look, if this negative sign's here, it also belongs out there. Whatever it is, whatever it's touching, that's what it is. So I can tell you right now, like this, whatever's going to be up there is going to be negative. Isn't that cool? That it's really easy. You don't have to worry about your signs then. If they're there, they're there. If they're not, they're not. All right, so what can I pull out here? Well, just an n. And then here, 2. So I have 3n minus 2 times n minus 2. How would I check to make sure it works? Foil it back out. I'm going to let you do that. Let's try one more, and then I think I'm going to let you try some on your own. Okay? Let's look at number 4 here. First question. Is there a GCF? There is no number that goes into 5, 19, and 12. Okay, so there's no GCF. Is there a leading coefficient? Obviously, it's a 5. So, draw your box. Where does this 5n squared go? Yep, upper left. Where does this 12 go? Yep, lower right. Now what? I multiply the two numbers. 5 times 12 is 60. And I list all the factors of 60. 1 in 60, 2 in 30, 3 in 20, 4 in 15, 5 in 12, 6 in 10. Which of those come together with the same signs, both positive, to get me a 19? There they are. 4n and 15n. So far, so good? Honestly, that's probably the hardest part, is just getting your box filled in. Once you have it filled in, it's just finding the greatest common factor. There's no common factor between 5 and 4, so I can only pull out the n. Greatest common factor between 15 and 12, 3. Greatest common factor between 5n and 15n, 5n. Greatest common factor between 4 and 12, 4. So I have 5n plus 4 times n plus 3. And that is using the box method. I hope that this has been a good demonstration on how to use the box method to solve or factor quadratics with a leading coefficient. I would like you to do the remaining even problems. Have a great day.